Okay guys, welcome to another tutorial. This time we're gonna talk about how to make some objects breakable in Box2D. So, I don't know, like smashing some rocks into walls and they break or something. I guess you're gonna find a use case for that. Beforehand, we are not gonna break them like they would be sliced in the middle or shattered. They're simply gonna disappear. So the fixture or the whole body, if you want, is simply gonna, like, you know, be destroyed, but not be split up in individual pieces, because that is also possible, but it is way more work and I cannot cover this in one tutorial possibly, if at all. So let's at first see what we have right here. This is a simple screen with Box2D stuff in it. This is kind of not what I wanted to do. I want to write Box2D breakable tutorial, alright? So this is what we have. Absolutely great. We have a ball and that box that I just threw out of the screen. There it is. And they do nothing. So as you can see, I'm not gonna explain to you how to create that ball and the box, because you should really know that if you want to do something like breaking them. And the mouse joint here, I'm also not gonna explain that. I made another video about it. Maybe I'm gonna put it in the description if I don't forget. But yeah, you can read how that all works in the show method right here. Basically, I just create the ground, create the box, and create the ball, and then move stuff around using a mouse joint and actually using one of my classes. So it just is less code, because that really doesn't matter for this video right here. The rest is just that I set the units per pixel, the unit scale, and some background color, render all the stuff on the screen, so you can all close this all down. I update the viewport if we change the window size, which we're not going to do anyway, and I dispose the world when we exit. Okay, so that's really nothing new. We just have the world, the renderer, and some viewport, and there we go. So this is enough for this stuff right here. Now let's get into actually breaking them. So there's a lot of things that you can break right here. So at first, let's probably begin simply breaking the fixtures of these. Well, they do just have one fixture each, but we can change that. At first, let's actually destroy the fixtures. So what we want to do is we want to react to collisions like this or like this, and we want to see if the force applied on the collision is over a certain limit that we can set, and if yes, well, destroy it. Instead of actually going through all the bodies every time and checking, we are going to use a contact listener. So for convenience, I'm just gonna let this screen here implement the contact listener, but it really doesn't matter. We just need some methods that are going to be executed. So at first, let's implement the contact listener, and this is gonna give us all these methods right here. Where are we gonna put them? Let's put them right here. This is going to give us all these 4 methods. We have to implement them all since it's an interface, but we only need PostSolve. This is the only method we need for our use case right here. So let's move all these here under this PostSolve method, and we can focus on PostSolve. Why do we choose PostSolve? Remember the order in which they are called. At first, begin contact when the AABB / the bounding boxes, the bounding rectangles of the 2 fixtures overlap, so there doesn't have to be an actual contact yet. Then pre-solve is called when they are going to collide, you know, before the actual colliding happens, before we actually calculate, before Box2D calculates where each body is going to go. Then in PostSolve, well, it just happened basically, and we get all the results of the impulses right here in this contact impulse parameter, which is what we're going to use to figure out how strong the forces have been. And then end contact when the AABBs / the bounding boxes of the 2 fixtures are not intersecting each other anymore. So this is where we need the PostSolve method. The collision just happened. We have all the results of the collision values, or whatever you want to call it, right here. And now we can see if one of these bodies is supposed to break. At first, let's figure out the 2 fixtures, because actually we don't want to break the whole body. We just want to break a fixture that's kind of nicer, more nicer, whatever, neater, better. Okay, you get it. So at first, let's say fixture fixture A equals contact get fixture A, and fixture B equals contact dot get fixture B. Probably import that. And right now we don't really have any values to check against. Let's just say they all break. No matter what happens, they break. So the first thing that we have to make sure is to not just destroy them right here, like fixture A dot get body dot destroy fixture A. This is how we would actually destroy it, but we cannot do that because we are in the PostSolve method right here, and the PostSolve method is called from the world.step method, and inside the world.step method, like right when it begins, the world is locked, so we cannot create, we cannot destroy any joins, fixtures or bodies. And yeah, this is what we're doing right here. We are destroying a fixture, so that doesn't work. We are just going to get a crash, and it's going to look really bad. Instead, we want to queue this for destruction. So let's go up here, or actually, yeah, let's go up here and create an array of fixtures to destroy. Yeah, that sounds good. New array fixture, and it's probably not going to be more than 2, so let's just say there are 2. And now we can put all these fixtures into the fixtures to destroy array and destroy them after the world.step method has been called. So instead we're going to say fixtures to destroy dot add fixture A. Let's just not destroy fixture B here, because that would be kind of boring, and destroy them right here. So after the world.step method, for fixtures to destroy fixture.getBody.destroy fixture. As simple as that. This is going to has to be restarted. Okay, so we just destroy all fixtures that are in this fixtures to destroy array, but we should also probably remove them from the array so that we don't try to destroy them in the next frame where they already have been destroyed. So fixtures to destroy dot remove value fixture, and yes, equals comparison should be used instead of dot equals. That's what this boolean parameter does here. Okay, so right now it should already work actually, except that we didn't set this whole thing as the contact listener yet. So in show, or actually in the let's actually go to show. Oh no, let's actually go to the constructor. It doesn't really matter. Let's say world.set contact listener this. Okay, so now we should be ready to test this. Box2D Breakable tutorial. Let me just copy this. Okay, so there we go. As you can see, both things have been destroyed. Okay, we are creating both the box and the circle in the same place, so they immediately kill each other. Let's just change that in the show method right here, where I create the ball. Let's just say, actually where I create the box, let's say we put this a little bit higher up. And then when I create the ball, let's put it back to 0. Okay, but we don't want to have too much of a look at the show method because you already know how stuff in there works. And let's just see. Oh, they still overlap. I'm sorry. Let's set this to 2. Do they still overlap? Yeah, just exactly on the edge. So 2.5. All right. Now that was cleaner, easier to see. Always one dies. Okay. Next, let's also take care of destroying the body if all fixtures of a body have been destroyed, just to clean stuff up, because right now stuff disappears, but we still have all 3 bodies in the scene. They just don't have any fixtures anymore, and this is just unnecessary. So let's simply destroy the bodies as well. Array body bodies to destroy equals new array body. Let's just say 2 as well. In case you didn't know, if you don't pass anything in it initializes with 16. So yeah, 2 is probably a better choice in this scenario right here. And for bodies to destroy, world.destroy body and bodies to destroy dot remove value body true. Okay, there we go. Now we just have to check. Let's actually make a separate destroy method that takes a fixture and say at first this, and second if fixture dot get body dot get fixture list dot size so the fixtures of the body of the fixture that we destroy, and of that the size, so how many fixtures does that body have, -1 because we're going to destroy 1 fixture. If that is smaller or equal to 0, or basically if it's smaller than 1, because then the body has no fixtures left anymore, bodies to destroy dot add body, well, fixture dot get body actually. Okay, and now let's use the destroy method in here to destroy fixture A. And it should still work just fine, except that it also cleans up the bodies of the fixtureless bodies. Yeah. Oh, I copied something again. Box2D breakable tutorial. Okay, and it's still the same. Now let's get to the interesting part, actually comparing the values of the impact to our limits that we still have not set. Now there's multiple ways to do with this, but we'll just use the simple way and put it in the user data. Of course, the user data is probably going to be used for something like sprites or other game related stuff, but yeah, in that case you should already have come up with a solution, because you probably want to put multiple things in the user data. So your user data class is going to look different from mine. But I'm just going to create it like right here, so we have everything on the screen. Public static class breakable info or something. Let's just call it breakable actually. And inside here we are going to put a few floats, like public float normal resistance and public float tangent resistance. Now why these names, I'm gonna explain that in a second. Also let's create some constructor right here. That is an awesome constructor, absolutely. Isn't there any better constructor? Yeah, this is what I mean. Okay. Oops. Okay, so now we can go ahead and create such a breakable instance, and that just holds these 2 resistances with the weird names that I'm going to explain in a second. We want to put such a breakable instance into the user data of the fixture to be able to compare against the values that we get from contact impulse. At first let's actually create some of these and put them in there. So in the show method we have this fixture of the ball right here, for example, fixture ball fixture. Or let's simply not put that in a variable and just say dot set user data new breakable Oops, we have a few other breakable in the classes here that are from my library, but don't get confused by them. Normal resistance is going to be, I don't know, let's say 1. And tangent resistance is going to be .5f or something. Doesn't really matter. And let's put another breakable into the box right here. So there we create the fixture. And oops, I just noticed that I don't dispose the ball shape. Ball shape dot dispose. Okay. So in the fixture right here, set user data, new breakable. And let's say, let's make it a little bit weaker than the ball. Actually, half as strong. Okay, so now the only thing that's left to do is to actually check the values inside of the breakable in the PostSolve method. So instead of just destroying it, we're first gonna get the user data from the fixture. So let's say we're gonna make another method, check for destruction or something. That's a stupid name. Let's say strain, because strain actually means that we are going to put some pressure on it, and you know, if it is too much pressure, it's going to be destroyed. So this takes a fixture again, and then we're just going to strain fixture A and fixture B, and inside here we're just going to check, oops, we actually have to give in the impulse, because otherwise we don't have any data to work with. So contact impulse, there we go. And now we can compare the data from the user data to the impulse. At first let's get that user data actually. So if fixture.get user data instance of breakable, so you know, just we know that it is an instance of breakable, but probably later in the game we don't know anymore. So let's just check that. And yeah, if it is, actually if it isn't, we don't want to do anything and we just want to return. But if it is, we are going to get the breakable fixture dot get user data and just cast it to breakable. Okay, now we can compare the values finally. So let's say let's actually have a look at what the impulse gives us. The impulse gives us get normal impulses and get tangent impulses. That's why we use these weird names up here, normal and tangent resistance. The problem is normal impulses and get tangent impulses are both given as a float and yeah, another float array, because there can be multiple impulses. Just imagine, I mean, in most cases it's probably not going to be more impulses here than 1 or 2 or something, but there can be multiple impulses if there are multiple points that the two fixtures collide with. So we just have to like add them all up and see if they all together are bigger than the limit. So let's just make another method right here, a mathematical one. Let's actually make it public static or something, because we can, and say float, and let's say sum that takes a float array values, and that's just going to return the sum of them. So float sum equals 0, and then for float value from values, let's say sum plus equals value, and then return sum. So now we got the sum of all the values in the float array, and then we can finally check if breakable dot normal resistance is smaller than impulse dot get normal impulses, but the sum of that, yeah, then we want to destroy it. So destroy fixture. That's the basic principle. Now let's do the same with the other impulses. So if breakable dot tangent resistance is smaller than the sum of all tangent impulses, then also destroy the fixture. And we can take this statement here and just make it part of this one. Okay, so let's try it out one more time. Box2D Breakable tutorial, and now we should be able to smash them down there and crash them. Yeah, that happened because I still had the mouse joint on the object that was destroyed on the fixture. Breakable tutorial, okay, but we should also be able to destroy them by using the friction on the ground because of the tangent resistance now. So there you see it, it worked. So if I just drag this down enough, down with enough force, yeah, it destroys the fixture as well, as simple as that. Okay, so we could also do this by almost the same principle, almost the same guideline for joints. We would simply put another resistance variable, actually two other resistance variables in here. But we cannot use the contact listener because joints are permanently being strained, if you want to put it like that. They don't just apply their force on collision or something, so we can't use a collision listener, contact listener. We would actually have to go into the render method and check this here every time. So let's say you set up some stuff where you want to check it, and then you have this joint called J. You could say J dot get reaction force and give it 1 divided by delta. And delta should actually not be this delta, but this delta right here. So 1 divided by 60. So 1 divided by the time step that you step the world with. Because as you can see, if I take this out again, it wants the inverse dt. So inf dt, that's what it wants, and it stands for inverse delta time. So we simply have to specify the delta time, and to inverse it we divide 1 by it. This would give us another float that we could, actually this would give us a vector 2, sorry, that we could then compare to the limits that we set. So it gives us a vector 2 because it gives us the force on each axis, on x and y. Also we have j.get reaction torque, which again takes 1 divided by the time step. But this actually just gives us a float, and yeah, is pretty much exactly what you can read here. So this is how you would check the limits for the joint. Yeah, well, that's basically it. How to make stuff break automatically. In case you're interested in not having to code this all yourself, yeah, who guessed it, I implemented this in libgdx-utils. So there's actually a class called Breakable, and you can use that if you're interested. Anyway, thanks for watching, and I hope I'll see you next time.